Okay, Dr. Lane, this is the assessment redo for the Monday kinematics assessment I missed. So what we have here is we have a diver. He's going to dive off or just jump off of a diving board into a pool. The diving board is 15 meters above the pool, and we're looking at a initial velocity of 6 meters per second. The unknown is the change in x, and then the time for the diver to reach the water, and then the velocity vector for the diver before it hits, or right before it hits the water. So first, I need to get my x and y components. So my acceleration for each, velocity initial for each, my velocity final for each, the change in x, and the change in y. Sorry if you hear my dog in the background, he's crying because I won't let him in. So my time for each, which they should be the same, but we'll, obviously we'll see. So my acceleration for x is going to be 0 meters per second. And then, I'm sorry, that's just 0. The acceleration for y, which of course I wrote this x over here, is going to be gravity, which is 9.8. It's going to be gravity down, so it's going to be 9.8 meters per second squared. Velocity initial for x is going to be 6 meters per second. Velocity initial for y is going to be 0 meters per second. We haven't found that yet. Velocity final for x should be 6 meters per second. This we don't know yet. This we don't know yet. Of course, this we don't know yet. The change in y is obviously 15 meters, as you can see here. Alright, so let's work it out. So first we should find the time, since that's going to be used in a few different equations. So alright. So we already know what velocity initial for y is, which is 0. So we can change this to 1/2 times acceleration y times time squared, which is 15 meters equals 1/2 negative 9.8 times t squared. So we can change it to negative 15 meters equals 1.9 times squared. Alright, and we get t equals 1.75 seconds. Alright. Alright, so sorry, I'm trying to get my lid. Alright. So next we're going to find our velocity final for y, which is going to be velocity final for y equals velocity initial y plus acceleration y times time. We already know that's going to be 0, so we can take that out. Equals acceleration y times time equals velocity final y is going to be equal to our gravity downward times our time, which we just found, which we're looking at equaling negative 17.15 meters per second. Okay. Put these in boxes so maybe it's a little bit easier to see. Alright, so I'm good. So I'll try to work it on right here. Alright, so next we're going to try to find the change in x. Alright, so that change in x is going to be equal to change in x over the change in t. It's going to be, we can move that equation around to show change of x, velocity of x times change in time, since we already have those two figures. Change in x, which is 6 meters per second times 1.75, and we're looking at a change in x of 3.343. I'm sorry, that's not right. Give me 1 second. We're looking at 10.5 meters. Alright. So finally we're looking for velocity vector. Alright. Alright. We're looking at 6 meters per second squared plus 17.15 squared. Which we're going to be looking at 18.17 meters per second. We're looking at theta equaling 70.73 degrees. All right. Hopefully I'm right. Thank you.